The IEEE International Conference on Rebooting Computing. The IEEE International Conference on Rebooting Computing is a premier event in the field of computing, bringing together experts from around the world to discuss the latest advancements and innovations in the field. The conference, held annually, provides a platform for researchers to share their findings, collaborate, and learn from each other. Key highlights of the conference. The conference features keynote speakers from leading institutions and organizations, providing insights into the latest trends and developments in computing. Researchers present their work in various categories, including artificial intelligence, machine learning, and data science. The conference also includes workshops, tutorials, and exhibitions, offering attendees a comprehensive experience. Sandia National Laboratories role in the conference. Sandia National Laboratories role in the conference. Sandia National Laboratories, a leading research institution, has played a significant role in organizing the IEEE International Conference on Rebooting Computing. However, the new research focuses on developing more precise and reliable models. The challenge of neural computing. Neural computing has been a cornerstone of artificial intelligence for decades. Inspired by the human brain's neural networks, these algorithms have been used to tackle complex problems in areas such as image recognition, natural language processing, and decision-making. However, despite their impressive capabilities, neural computing has been plagued by issues of accuracy and reliability. Approximate and fuzzy. Historically, neural computing has been seen as approximate and fuzzy, with models often producing results that are close but not exact. This has led to concerns about the trustworthiness of neural computing in high-stakes applications. Lack of rigor. Traditional neural computing approaches often rely on heuristics and trial-and-error methods, which can lead to inconsistent results and a lack of rigor in the modeling process. The new research approach. A team of researchers at Sandia National Laboratories has been working on a new approach to neural computing that aims to extend the field's capabilities by incorporating rigor and predictability. This new approach focuses on developing more precise and reliable models that can produce accurate results in a wide range of applications. Key features of the new research. Mathematical rigor. The new research approach emphasizes the use of mathematical rigor and formal methods to develop neural algorithms. This includes the use of techniques such as linear algebra and calculus to ensure that the models are well-defined and consistent. Predictability. The new research also focuses on developing models that are predictable and reliable. This involves using techniques such as model validation and verification to ensure that the models are accurate and consistent. If you're not careful, you can end up with an algorithm that's learning to exploit vulnerabilities in the system, rather than improving the system itself, he warns. The risks of continuous learning. Understanding the challenges. Continuous learning algorithms are designed to adapt and improve over time, but this approach also introduces new risks. One of the primary concerns is that these algorithms may learn to exploit vulnerabilities in the system, rather than improving it. This can lead to a range of negative consequences, including data poisoning. The algorithm may learn to manipulate or distort data to achieve its goals, leading to inaccurate or misleading results. The basics of dynamical systems. Dynamical systems are mathematical models that describe how a system changes over time. They are used to study the behavior of complex systems, such as population growth, weather patterns, and financial markets. The key characteristic of dynamical systems is that they are governed by a set of rules or equations that determine how the system evolves over time. The rules or equations that govern a dynamical system are often nonlinear, meaning they do not follow a simple linear relationship between variables. Dynamical systems can be classified into different types, such as discrete time systems, which update the system's state at discrete intervals. Continuous time systems, which update the system's state continuously. Stochastic systems, which incorporate random elements into the system's dynamics. Applications of dynamical systems. Applications of dynamical systems. Dynamical systems have a wide range of applications in various fields, including physics and engineering. Dynamical systems are used to model and analyze complex physical systems, such as chaotic systems, which exhibit unpredictable behavior. Biology and ecology. Dynamical systems are used to study the behavior of populations, ecosystems, and the spread of diseases. Economics and finance. Dynamical systems are used to model and analyze complex economic systems, such as financial markets and the behavior of economic indicators. Computer science and artificial intelligence. Dynamical systems are used to build machines that can learn and adapt to new situations, such as neural networks and deep learning algorithms. The concept of neural networks and numerical algorithms. Neural networks are a type of machine learning algorithm that mimics the structure and function of the human brain. They consist of interconnected nodes or neurons that process and transmit information. In the context of numerical algorithms, neural networks are used to solve complex problems by learning from data and improving their performance over time. Key characteristics of neural networks. Distributed processing. Neural networks process information in parallel, making them efficient for complex tasks. Learning and adaptation. Neural networks can learn from data and adapt to new information, allowing them to improve their performance over time. The rise of neural computers. The field of computing has long been dominated by traditional computers, which rely on algorithms and software to process information. However, with the advent of neural networks, a new paradigm has emerged that could potentially revolutionize the way we approach complex problems. Neural computers, in particular, have the potential to solve tough math problems quickly and efficiently. What are neural computers? Neural computers are a type of computer that uses artificial neural networks to process information. These networks are inspired by the structure and function of the human brain, with layers of interconnected nodes that process and transmit information. Unlike traditional computers, which use algorithms to solve problems, neural computers use a more organic and adaptive approach to processing information. Key characteristics of neural computers include adaptive learning. Neural computers can learn from experience and adapt to new situations. The conference will feature a keynote speaker from the National Science Foundation, NSF, and a panel discussion on the future of computing. The conference, a celebration of innovation in computing. The conference, titled Computing, The Next Frontier, is a celebration of innovation in computing, bringing together experts from academia, industry, and government to share their experiences and insights on the latest advancements in the field. The event is being held at the University of New Mexico, a hub for research and innovation in the region. Keynote speakers and panel discussions. The conference will feature a keynote speaker from the National Science Foundation, NSF, who will provide an overview of the agency's vision for the future of computing. The speaker will discuss the NSF's initiatives and programs aimed at advancing computing research and education. The keynote speaker will also highlight the importance of diversity and inclusion in the computing field, emphasizing the need for more women and underrepresented groups to participate in computing research and development. A panel discussion on the future of computing will feature experts from academia, industry, and government, who will share their perspectives on the latest trends and challenges in the field. The history of innovation in computing. The conference kickoff talk will be given by Sandia's Chief Technology Officer, Rob Leland, who will provide an overview of the history of innovation in computing. Leland will discuss the key milestones and breakthroughs that have shaped the field, from the development of the first computers to the current era of artificial intelligence and machine learning. The talk will cover the contributions of pioneers such as Alan Turing, Ada Lovelace, and Steve Jobs, who have played a significant role in shaping the computing industry.